Okay, so this is basically a practical component, testing and evaluation, the last chapter that we had to finish. And basically this is talking about errors. There are different types of errors that we come across when you're writing a program. One common type of errors is logical error. Now, logical error occurs when we don't get what we want, right? We are not getting what is intended. The intended result is not coming, right? And usually this happens due to a miscalculation. Now, this miscalculation can happen when you don't follow the BOD mass or the bid mass. So according to the BOD mass, first you have the brackets, then you have to do the indices or the power, and then you do the division or multiplication in whichever comes first, and then you do the addition and subtraction whichever comes first. So keep that in mind, right? Okay, now here you can see there's a possible logical error. What is the logical error here? You insert a number 1 and insert number 2, and then you are supposed to calculate the average by dividing number 1, the total of number 1 and number 2 by 2. But because of not following the BOD mass, we are not getting the correct result, the intended result, right? So we need to put the brackets there and then get the total first and then divide. So that's the problem there. Okay. So logic errors are common, but what is most common is the syntax errors, right? So syntax errors occur when you don't follow the rules and guidelines of the programming language, when you don't follow the rules and grammar. So they often occur when you write the code. But then when you run the code, you will see logical errors where you don't get the intended result. And then we have another type of error called runtime error. Now, runtime error causes the program to stop suddenly. And runtime errors, we can't really expect when it is going to happen. So we'll talk about runtime errors in a moment. But syntax errors, of course, we can avoid when we are typing the code, because the programming language or the interface that we are using allows us to find out where the syntax error occurs. But whatever it is, an interpreted language will stop. Now that day we saw, no, interpreters and compilers, interpreted language will stop when there's an error. So then we have to correct the error and run again. So syntax errors, of course, we can correct while typing, and then logical errors, of course, we need to make sure that we have got the logic correct or the calculation correct. So having an idea about the BOD mass helps us to avoid logical errors. Let's see how to find logical errors in a moment. That's why we are going to talk about the trace tables and dry run. But right now, some logical error examples, right? Okay, so here there is a logic error. Can anyone spot the logic error here in this code?
So the index isn't defined because it just
defined, but index is defined in the wrong place, right?
yes,
Yeah.
sir.
So where should it be defined?
Set index to 1 should be the part, I think so.
Out of the while loop? Out of the while loop, excellent. Yeah. Okay, good try, Amar. Good try. And Naila, yes, correct. It should be defined outside the while loop, right before the while loop, right here. Because remember, I told you, like when you do the while loop, there are two important things. One is the initializing, second is the increment, right? So initializing has to be done before you enter the while loop, because you have to satisfy the condition. So the condition is index less than less than 10. If the condition is less than 10, index has to be defined to index has to be initialized to a value where the while loop condition becomes true. So if index equals 1, 1 is less than 10 becomes true, because this is a precondition loop. So the condition has to be satisfied to enter the loop. Okay. Right. So that's the logic error. Otherwise, what will happen? This will keep on, right? In fact, this will give an error if you try to run this. It will say index is not defined or something because we can't enter the while loop. But according to the pseudocode, what will happen is index is set to 1 and it will be output, and then it will be incremented by 1, and then again it goes and it goes and checks index is 2, 2 is less than 10, and then again it sets to 1. And then it will output 1, and again it becomes 2 and goes there and checks 2 is less than 10, true. Again it sets to 1 and prints 1. So it will keep on printing 1 without stopping. Will we get this for exam? Well, I can't really tell you whether you get this, but this chapter has to be done. Okay. Trying to get some points from me, I know what you ought to, but this has to be done. This chapter has to be done. Just because I'm out of school, I can't really tell you what's there in the exam. Okay. It's not ethical, no. But I made the paper. I made the practical paper. I made the practical paper for grade 10 and 11. Okay, so it will be an infinite loop. It will be an never-ending loop, right? Continuous loop, never-ending loop, infinite loop. So how do you correct it? By this. And then remember, if you don't put the increment also, it will keep on going without stopping. So the increment has to be there and the initialization has to be there because it's a precondition loop. Okay, let's find out the errors here. Find and correct the errors. There are some logical errors in these. What's the problem with the first one? Can Rushda tell me? What's the problem with the first one? Okay, let me highlight them then and share. Rushda, quickly try to spot the error in this, the logical error. In the first one, yeah, what's the error? Where's the error? Hurry up, I'm having a power cut. My battery is draining really fast. Rushda, what's the problem in the first one? What is the logical error? Logical error means it's not giving what is intended. Syntactically, it's fine. Runtime error, we can't really find out because this is a pseudocode. We don't run it. We haven't run it. So it's the logical error that we are trying to find. Come on. Spot the error.
Logical.
Yeah, what's the logical error here? This one. Anyone else?
Says it's the index plus index plus one index plus.
Yeah, that's right. It's called increment. Okay, there's no increment. Index equals index plus 1 is missing, so it won't increment, and because it doesn't increment, it doesn't reach the target. Right, when it is exiting the loop, it should be 10. The value of index should be 10. Right, the last value of index will be 9. 9 is less than 10, it's true. When it is 10, 10 less than 10 is false. So the last value of index will be 10. And it doesn't reach 10 unless you do the increment. Okay. Can anyone tell me the problem with the second one?
They're the same index to the second.
Yeah, the problem is here, right? Set index is index -1. So you are starting index with 1. 1 is less than 10 is true. You output the index, so the 1 will be output, and then this becomes 0. And it goes there and checks 0 is less than 10 is true. Then output 0, and then it becomes -1. Right. So the purpose of the program was to print 1 to 10 numbers.
So would this go infinitely if you were to type this?
Of course, no. Infinity.
Okay, sir.
Minus, 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 never ending. Right? So the purpose was to print 1 to 10, but it goes the other way, right? Okay, what's the problem in this one?
The index should be less than 1 for the loop to end.
Less than, this should be less
So
than, right?
the condition isn't used because the index is already
Yeah,
the same value as 1.
exactly. Exactly. Now this should be, I mean, how do you correct it is by putting 10, but the problem is it doesn't enter the loop, right? In the
Yes, sir.
first place, it doesn't enter the loop. Why? Because index is set to 1, right? And 1 is less than 1 is false. So it doesn't enter the loop because these are uh, precondition loops. Precondition loops. Okay. So this one, it doesn't enter the loop. Just a minute, I just got the power. Doesn't enter the loop because it's a precondition loop. Okay. Right, let's go to trace tables. Trace tables are used. Oh, what's the message you are saying? Last year's paper, possible to get the last year's paper? Well, the theory one, well, I'm going to do the papers in those classes. That's what I'm going to do. Okay. If you really want to get the paper, you can ask from Tusharika ma'am because I have shared that paper. I think it was a practical paper I shared, but you can get that from her. Otherwise, now today is the last general class. I'll be starting the paper classes from Monday. Monday onwards, I'll be discussing papers. Okay. Right. If you want online classes, I can do online classes. If you want physical classes, that can also be arranged, right? That's until I the leave the country. But after the exam, I'll be doing classes to complete most of the syllabus as much as possible before I leave. Because I don't want to kind of disappoint you. I want to kind of help you guys until I leave. I heard some people have already left the subject also. Right? Okay. So even if I go there, I will stay in touch with you guys. I'll be doing classes until you do the final exam. Right. Because I don't like to kind of leave a batch halfway through and exit. Right. So trace table, it's a formal way of checking for logic errors. right? Trace table is like a truth table that we did last time. Similar way, but the purpose of this is to trace. Trace means you are tracing the pseudocode. You are going through the pseudocode. You are traversing the pseudocode, right? And when you are traversing, what do you do? You look at how the code behaves. Now, remember, this is done before implementing the code. Before implementing the code, right? So trace table is used to trace the pseudocode. So before implementing, we don't have the code, right? So only code we have is the pseudocode. So we do it on the pseudocode. But sometimes in the papers, they might give the actual code and ask you to fill it or do it, fill a trace table. No problem. Only thing is you have to understand that that is the real code, right? So if you have a for loop in that real code, you have to keep in mind that for loop doesn't go up to the upper boundary. If it is a pseudocode like this, you should understand that the for loop will go from 1 to 5 without any problem. If they gave the same code in actual code, you have to remember that for loop goes only one less than the upper boundary. Just that, right? Other than that, the method is the same. Okay, let's see how we can do this, right? Right, so trace table. We are given an algorithm in the form of a pseudocode. We had to do a trace table like this. So it's really easy. What we do is we have to identify the variables that we have used in the pseudocode. Okay, variables along with the output. Right now, try to understand this very carefully, right? It's nothing, there's nothing in this. Right. So what we are going to use is a trace table. This table is called trace table. Using the trace table, when you do a trace, when you trace the pseudocode using the trace table, it is called dry run. Dry run, right? That is going through from top to bottom in the pseudocode while filling a trace table and tracing the pseudocode from top to bottom is called dry run. So often they will say in the question, do a dry run on the pseudocode and fill the trace table. That's what you do. Okay, what do you have to do? You have to identify the variables used in this and the output. Okay, here's one variable, number. Here's another variable, index. Here's another one. Here's another one. And finally, we have number 2 going to display. So this can be called output. Understand? Did you understand how we selected the variables?
Yes, sir.
All right, just give me a minute. Let me put a message to the next class. Yes. Minute. I'll tell you. Can you guys create a table like this with these variables in your exercise book? Number, index, number 1, number 2, output. And let's do it together. Quickly. Okay, finish. Right, so number 1, number, index, number 1, number 2, output. So to show this to you, I will use an Excel sheet. Okay, so I'm going to have these variables, number 1. Sorry, first is number. And then comes the index. You have to select these variables from top to bottom in an order. Then comes the index in the for loop, and then comes the number 1. Then comes number 2. And then finally comes the output. Okay, ready? Shall we do the right now on the trace table? Yeah. Shall we?
Yes, sir.
Others? Can I see a thumbs up?
Okay, sir.
Thumbs up? Quick thumbs up? What a match, no? India is losing. Okay. I'm watching the match also while doing this class. Right.
Sir, I was doing that.
You also watching the nice match, nice match. India should lose. Okay, so set number to 3. Okay, now you are starting from top to bottom. Top to bottom. Set number to 3. Right. So what you do is you fill 3 there. Okay. Then we come to the index. Index will start from 1 and go up to 5. Okay. So that 1, you can put it right here, or even here, it's fine. If you have space in the paper, in the table that they have given, if they have given a table, make sure that if you have space, you can put it here. And if a number doesn't change throughout, you can just leave it blank after that, or you can put 3, 3, 3 like that if it doesn't change, or even you can put dash, dash, right? If that doesn't change. Okay, so I'm going to put index 1 here, okay? Because I go to the second line. Index is 1, and then I enter the for loop. Set number 1 to number multiplied by index. Number is this, index is this. These two multiplied, it will be 3. So number 1 will be 3. Simple. Now that also I can put it in the next row, but then I'm thinking of the space here, so I just put it there. It doesn't matter. It's the what matters is the order that you execute, not really these lines. Okay, even if you put 1 there and 3 there, it's fine. Okay, so I executed this one, set number. So this is what dry run is all about, right? So we are not writing the code. We are just going through the pseudocode and filling this, right? Okay, so you also do it. Set number 2 to number 1 multiplied by 2. So that means you double number 1 and set number 2. That means it's going to be 6. Is there, okay, now then there's a question. Is number 2 greater than 20? Which is not. If number 2 is greater than 20 only, there will be an output. So will there be an output now?
No, sir.
No. There's no output. So just leave it. Okay. Right. Now it comes to the next loop. In the next loop, index is going to be 2. Index is going to be 2. So no change for 3. Just leave it there. No change. If you want, you can put 3, 3, 3 like that. That's also fine. If there's no change, just leave it. Okay, when it is 2, when index is 2, set number 1 to number multiplied by index. So number doesn't change, right? This number doesn't change. So set number 1 to number multiplied by index. Number is 3, index is now 2. 3 into 2 is 6, right? And then set number 2 to number 1 multiplied by 2. So number 1 multiplied by 2 means you double the number. So it's 12. And still it's not greater than 20. So there's no output. Okay, now it goes to the next loop, where this time index becomes 3. Right? When index is 3, set number 1 to number multiplied by index. Number is 3, index is 3. So number 1 is going to be 9. And number 2 will be doubled. Right? Now you see the pattern, right? There's no output still because 18 is not greater than 20. You also do it, right? Okay, it goes to the next loop. Index becomes 4. Set number 1 to number multiplied by index. Number is 3. Index is 4. And it's going to be 12. And number 2 will be double this. Right. Is there going to be output now?
Yes.
Yes, sir.
What a hit, no? 6. Yeah, there's going to be output. Why? Because this is greater than 20. So what is the output? Number 2 to output. That is 24 will be output. Okay. Right. So one more loop to go. Goes back. This time index will be 5. Set number 1 to number multiplied by index. Number is 3. Index is 5. So multiply. It's 15. Correct, no? 15. And then number 2 is double this number. So it's going to be 30. And is there output?
And there is output, sir.
There is output and that is 30, right? Which is number 2. Okay, so we have finished all the loops.
Yes.
We should go from 1 to 5. Index 1 to 5. And it's over. So ultimately, we should get 2 numbers as output, right? 24 and 30. Yeah. Right. So that's how we do the trace table. It's so easy. Right. Now, after doing the trace table, normally what we do is we try to locate any logical errors. Now we don't think that we have a logical error. But how do you confirm? Wait a minute. Then screen.
So,
Yeah.
so without filling in that whole thing, can you find the answers for the first 2 and then find the pattern and fill in the rest?
Yeah, most of the students do that, right? But I don't suggest that, Atma, because um, it's better to the purpose of dry run is actually to go through the whole code, run through the whole code, right? And the chances of doing mistakes is high if you try to find the pattern and fill it. It doesn't take much time. Finding the pattern kind of allows you to like keep an eye on how it actually works, right? But just because you find the pattern, don't try to fill everything and finish it off quickly, because it can lead to some errors. Okay, mistakes. Right. So once you do that, what we have to do is to confirm we can run this and see whether we are actually getting those two as output, right? So let me show you. Number 2, 3 for index in range 1 to 5. 1 to 5. Now here, of course, you have to do a change, right? If you put 1 to 5, it goes only 1 to 4. So you have to make this 6 because you need to go from 1 to 5. No, that's the thing, right? So if they, instead of the pseudocode, if they gave the actual code and ask you to do a dry run, remember this one. It goes only 1 less than the upper boundary. So if they gave like 5, right, your loop should be going from 1 to 4 only. So they might, cunningly, they might give a actual code for the dry run, right? So if this is given, then you should understand it goes from 1 to 5. Okay. Number 1, 2, number multiplied by index. Number 2, 2, number 1 multiplied by 2. If number 2 greater than 20, print number 2. Okay. There you go. You get 24 and 30. That's what we expected, right? That's what we expected out of the dry run, 24 and 30. And that's how you locate logical errors and correct them. Clear? Is that clear? So
Yes, sir.
can you do a dry run now?
So dry run the code.
Yeah, I mean, can you do dry runs using trace tables now?
Yes, sir.
Yeah. Okay. So here's another dry run. This you can do it on your own. X and Y. Now that's based on the Python code, right? Okay, great. You tried the code, no? Yeah. So after the class, you do this before you go to sleep. Python code is given, actual Python code. You do a dry run on this. Y equals 2. You can see y equals 2. X equals 1. X starts with 1 and goes up to. Right now here it's tricky. Why? Because it's an actual Python code. So it goes only up to 6. Can you see? It goes only up to 6. Right, so don't look at this one. Just do the dry run for this one and then compare it with the trace table. So what are the variables we have? We have y, we have x, and we have output. Output is y. But you can see the output comes after the for loop. After running the for loop only, the output comes. Not inside, right? So that's why you can see here, after completing the for loop, you get the output, right? So try that. Okay, syntax errors, of course, you know that syntax errors occur when you don't follow the rules and grammar of the programming language, like misspelling, missing out a closing bracket. Now, bracket, of course, not used in Python. I can say missing out a colon, missing out quotation marks, and then runtime errors. Runtime errors occur when the program is running, and this can be due to some unusual or unexpected error. Okay, so runtime errors occur when the program runs, and an error that occurs while the program is running, the operation the computer is asked to do is impossible to execute. Right. So even other errors, interpreter will stop. But here it occurs because the program cannot really continue, cannot execute. It's a system problem, system error, right? Not really, other types of errors. But if it is a syntax error, or if it is, if it is syntax error also, the program will stop because it's an interpreted language. But this stops because it simply cannot execute further. Right. One of the most common runtime error is zero division error. Zero division error. That is, if you divide the number by 0, this error occurs. I don't know whether you have seen this error. Have you seen this error? Zero division error, and it comes in the calculator also. Right? Have you tried it in the calculator? So you can do it here in the shell. You take a number, divide it by 0. Division by 0 or zero division error. Try it in the calculator, you get this source, this there as well. So to solve this, you need to check whether you are actually going to divide by 0. So when the number is there, when the user enters the number, you have to check whether he enters 0 or not to avoid the zero division error. Okay. Understand? Yeah. Others? Understood? Zero division error is a runtime error, is an example of a runtime error. Okay. Yeah. By the way, how many of you are watching the match and listening to this? Just to be curious, Amar is there. Huh? Anyone else watching the match and listening to this? I mean, Amar, myself, and anyone else? No. So Indians are learning a lesson today. Not to be overconfident. Okay, right. So zero division error is a runtime error. Okay. Right. Logical errors. So what are the types of errors we have? Logical error, syntax error, and runtime error. Okay. Finally, we come to this one. Just a quick go through of this. IDE, we talk about something called integrated development environment. Integrated development environment is basically the interface provided by your programming language. Right? The tool that you use to write the programming language is the integrated development environment. If it is Thorny's integrated development environment is this. So you have the menus, you have the code window, you have the shell, you have the help window. All these are part of the IDE, integrated development environment. Okay. And these interfaces. Now, Python's default IDE is not that, not Thorny. Okay, if you go and search, you will find something called Python idle. That is the default IDE of Python. Thorny is another software developed to run Python language. So these IDEs, they help the programmer a lot to write the code better, to find errors, debug them, and also to type code faster. So what are the things that they provide us? Here are some error messages. Yeah, okay, before that here. There are some useful features provided by the IDE. So one popular method is highlighting the errors. When you type, it will highlight the errors, such as the syntax errors, so that you know that you are doing a mistake. Syntax highlighting. Right? Okay. Syntax highlighting. Then autocomplete. Right? Have you seen autocomplete? You type part of the code and then it'll automatically, when you press tab, it'll complete the code. Then also tooltips. It shows tooltips on how the code should be completed, showing the syntax. Auto indent is also there. Auto indent. So it makes it less stressful for the programmer and makes typing the code faster and more efficient. One of the most useful features of IDE is the debugger. Debugger helps us to find errors. Right now here in Thorny, it's the shell which shows all the errors. So this is the part of the, this is the part which debugs, which helps us to debug. It shows where the error is, it shows what the error is, right? It gives a user-friendly message of the error. Right? That is also part of these IDs, right? It is really important that you get lots of practice interpreting error messages and fixing errors. So in the exam also, that's why I told you it's very important that you understand what the error message is telling us, right? So some of the popular error messages: syntax error. You know what syntax error is? Not following the rules. Indentation error, if you don't indent in Python properly, because we don't use brackets there. So indentation has to be there. If you don't indent after the colon, there will be indentation error. You have type error, that is you are trying to deal with different data type, like this one. Can't convert int objects to string implicitly, trying to join a string. When you're trying to join a string and a number, it doesn't allow unless you convert that number into string. A type error, data type error. Zero division error. You are trying to divide the number by 0, right? And name error. Name error occurs when you are referring to a variable that is not defined, right? You have asked, you are trying to use a variable, but it is not defined or initialized. So the program doesn't know where the variable comes from. These are some of the different types of errors. Okay. Right. So can you tell me the error here? What's the error here? What's the syntax error there? in this one?
Indentation?
Not the indentation, no?
No, sir, brackets.
Yeah.
No, quotations.
Quotations after the text, the quotation should be there before the variable name, right? Mm, okay, test plan is there. Let me get back to you in a moment. Okay, children, we don't need to do the test plan. It's not coming, right? Okay, so I think that's enough. I think in hardware we have few things to be looked into, like not in a big deal. I'll tell you what those things are. Yeah, we need to talk about a little bit of cores and buses. I mean, not in great deal, but what cores are and what types of buses we have. But already in the previous lesson, I told you like we have buses for various tasks like data bus, address bus, and control bus. So just not in detail, but just Australia. Okay, in my one, Australia has two more runs to win. Okay. Okay, so we need to do cores and buses little bit that I will do. Other than that, everything is complete. So I'm going to start the papers from Monday, but that is in these classes, the private classes. I have online classes and physical classes also. If you want, physical classes can be arranged. Just register there, and then I'll come back to you, right? So practical, theory, both are done. Only thing is that course and buses has to be done, small part, not in detail, just to tell you like what cores are, why the advantage of having course, and then what are buses. Bus, you already know what bus is, what are the types of buses, and that's it, what they do. Okay, do you have any questions?
No, sir.
No, no. Right. Okay then. See you. I'll see you in the. I'll see you soon. I'll be marking your papers by the way after the exam.
And theory paper,
What?
even the theory paper, are you noting?
Theory paper? Am I marking?
Yeah.
I'm marking both papers.
Okay, sir.
Right. But your exam is next week, right? I mean, computer science.
Yes, it's after next week. Next week.
Hold
It's
on.
the 30th and 1st.
30th and 1st. All right. So we have time now. 30th and 1st, or these two. Right. So I'll be starting the paper classes from here. And as we go on, I might increase the sessions because I want to do a practical paper, complete practical paper, and a complete theory paper before you take the exam within this time period, right? Okay, so tell others also. I'll see you around. See you then.
Okay, okay.
Thank you, sir. Good night,
Thank you,
sir.
sir.